So a very powerful tool, the Powerlog. So I think one thing though that you kind of missed in the explanation is the whole big thing. I mean, obviously we're actually going to probably link the description, the video below for those who want to go and watch it. But the biggest thing with the whole Powerlog is that it is to multiplication what it is to addition, right? With that whole and it kind of takes exponentiation's place almost.
Yeah,
which
yeah.
is what you kind of wanted it to do.
Yeah, so in a certain sense, it takes exponentiation place. Like, I was kind of being hyperbolic. Like, exponentiation is the next tier up for multiplication in the normal sense, but this is still the next tier up for multiplication in a different sense. But yeah, this new operation is the next step up in the sense that it is exactly to multiplication as multiplication is to addition. It's exactly the same, you know. So it's the exact same algebraic relationship preserved. And one of my exercises was, okay, we can get this new operation by kind of going in the opposite order. We ended up finding this isomorphism with e to the x is like the translator code, you know? Mm-hmm. So I was like, okay, so we can use this function to get the new operations. So can we take the natural log, you know, that's e to the x going the other way. Can we get negative tier operations? And you can. If you go natural log and you just keep carrying the operation that way, you can get the negative 1 tier operation, you know, that's below addition. And what I found is that if you take this limit, like if you keep bringing the operation down, it turns into the max operation. So it just tells you the maximum real number out of the two real numbers you input. Because maximum is another binary operation. Yeah, so that's like the negative infinitieth operation in this sequence is max of A and B.
Is there a reason, or that's just what happens when you go all the way down?
The reason is that we keep applying this mat over and over and over again, and what it's doing is that we have the exponential nested inside a bunch of times. So when we input these two values, one of them they're both going to blow up, but the fact that it's a bunch of exponentials means that whatever difference there is, it's going to be super magnified. You know what I mean? Like if you have e to the x, you know, and you look at you plug in 2 to it and you plug in 8 to it, that's going to magnify the difference, right? The difference is going to be much bigger than the difference between 2 and 8. One of them is going to be, you know, moderately large number. One of them is going to be a huge number.
Right.
And you keep doing that, so it's changing the difference so much between these two numbers, so that one of them basically becomes irrelevant and the other one's blown up out of control. But then you have a bunch of natural logs outside, so it just wipes it all out and brings it back down after making one of them irrelevant. That's kind of what's going on there.
So in the limit, it just reduces it right back to just the biggest one.
Yep,
wow.
That's right. Yeah, in the limit. Yeah.
Wow, it's kind of beautiful. It's kind of almost beautiful.
Yeah, I thought it was cute.
And
it's kind of cool.
And I'm guessing if you go the other way, it just goes to infinity.
I didn't see anything happening, and some commenters solved that. It seems to be that it doesn't do anything interesting, like in the other direction. It doesn't. In other words, it doesn't approach anything. It just keeps kind of like blowing up out of control in a certain way.